Okay, so we are going to be talking about vectors today. We'll be going back and forth between the vocabulary handout and then more like the problems handout. But for the most part, we'll just be using the vocabulary handout for the most part. But we will be going back and forth a little bit. So first, let's define a vector. A vector is a quantity that has both magnitude and direction. And it's customary to use an arrow when we're talking about vectors. So we're talking about little arrows, little rays, basically. So we mentioned this word magnitude. Magnitude is the length of the arrow. And its direction is the arrowhead. We have two different types of notation when we're talking about vectors and magnitude. Oftentimes you'll see boldface. If it's typed. And then if we're talking about just handwritten, arrow over the letter. Okay, so as you look through your notes, you'll see a lot of boldface, a lot of letters in bold. But if we're doing just handwritten, you'll often see an arrow written over the letter, the vector that we're talking about. So then we have what is called a directed line segment. This can also be called a geometric vector. And this orders the points so that they proceed from P to Q. P and Q, they both have more specific names. The first one is called the initial point. And that one is P, which is our starting point. And then we have what's called the terminal point. In this case Q, and this is our ending point. starting point, you'll notice that above it would be the end point of that ray, and then Q, that's our ending point. It shows us the direction that we're going, so it's going towards point Q. Next we have the 0 vector. And a 0 vector has no magnitude. The magnitude is 0. And there is no assigned direction. Vectors. And equal vectors have the same magnitude, and the same direction. However, they can have a different initial and terminal point. Next we have adding vectors geometrically. So we're going to take two vectors, v and w, so v plus w is the new vector, whose initial point is the initial point of v and whose terminal point is the terminal point of w. And we're going to take a look at that in a moment when we start to graph. And then we have multiplying vectors. And we multiply vectors with what are called scalars. And those are just real numbers. And they only have magnitude. So if we say 0 times our vector, we have 0, vector is the opposite of the vector, which again, we'll take a look at that when we start graphing here in a moment. If you need to pause, go ahead and pause. Let's see where we're at. Unit vector. So the unit vector magnitude, this is the magnitude, is kind of like in a double absolute value type symbol. That's our symbol for magnitude. I should have mentioned that up here. So back with magnitude, magnitude of V. So the unit vector, its magnitude is equal to 1. So our unit vector then is our vector divided by the magnitude of the vector. So that is a unit vector with the same direction as V, as the original vector. Next we have the algebraic vector. This looks like an ordered pair, except we have these little V's on either side. Oftentimes this is called component form, and I'll probably refer to it more as component form than I will as an algebraic vector. A position vector is an algebraic vector with initial point P sub 1 with an ordered pair of x1, y1, and terminal point P sub 2 of an ordered pair x2, y2. Okay. So if our vector is equal to P1, P2, then the vector is equal to an algebraic form or component form x2 minus x1 comma y2 minus y1. Next we have horizontal and vertical components. We have the letter I, and that's equal to the component form 1, 0. And then we have J, and that is equal to the component form of 0, 1. So V is equal to equal to A times 1, 0 plus B times 0, 1. So that this is equal to AI plus BJ. Okay, so vector AB, component form AB. A is equal to the component form 1, 0, and we said that that component form 1, 0 is I, so AI. And then B times this component form 0, 1. We said 0, 1, that is J. So AI plus BJ, that's the exact same thing as the component form. So they just have two different notations. Okay. So A is the horizontal component. And B is the vertical component. Equality of vectors. If V is equal to A1, B1, and W is equal to A2, B2, then V is equal to W if and only if A1 is equal to A2 and B1 is equal to B2. And that should make total sense there. Alright, so now we're going to talk about the add and subtract vectors algebraically. So there are, let's see, 4 different properties here. So first we're going to say that V is equal to A sub 1 I plus B sub 1 J. So that would be equal to A1, B1. And W is equal to A2I plus B2J. So that's A2, B2. Dot, dot, dot. Now come our 4 properties. The first one, V plus W is equal to the quantity of A1 plus A2 I plus the quantity B1 plus B2 J, which is equal to A1, oops, that's not right, which is equal to A1 plus A2, comma, B1 plus B2. Totally ran out of room there, sorry. Number 2, we can subtract V minus W. So A1 minus A2 I which is just A1 minus A2, comma, B1 minus B2. Number 3. If we have alpha V, that is equal to alpha A1 I plus alpha B1 J, which is just alpha A1 comma alpha B1, which is a scalar, where alpha is a scalar. And then number 4, we're coming back to magnitude. Again, our symbol for magnitude, I like those double absolute values. And the magnitude is equal to the square root of A sub 1 squared plus B sub 1 squared. So if we take a look at this, this is just like the Pythagorean theorem. Okay, because we're going to be talking about some vector. Let's say this is our vector right here. If I were to drop down a vertical, remember A is our horizontal component, B is the vertical component. Here's that vector, V. We're trying to find its distance there. Okay, so we're just using the Pythagorean theorem. Okay, so let's go ahead and graph some vectors. So you should be, I believe, in the second handout at this point. I think there's still some things that we need to finish in the first one, but we'll get to that in a little bit, maybe even tomorrow. So let's take a look at the graphing. So we are given 3 vectors. We're given vector V, where I would be going up 2 units and to the right 3 units. There's vector V. I have vector W, where I'm going down 2 units and right 2 units. And I have vector U, that's going up 3 units and right 1 unit. Okay, so we're going to graph these, some vector additions here. So the first one that we have is V minus W. V minus W. So the first thing we're going to do is we're just going to draw vector V. So again, for vector V, we're going to go up 2 units and right 3 units. And now we're going to, this is like saying V plus the opposite of W. So W goes from upper left to lower right. So we need to go in the opposite direction. So instead we need to go up towards like a northeast direction to show that we are subtracting. So again, my horizontal component here is 2 units. Then the vertical component is 2 units. But I need to go in the opposite direction. So I'm going to go left 2 units and then up 2 units. negative W. So when I combine them, going from the initial point of V to the terminal point of W. Anybody remember what that's called? That's called the position vector. Okay, so then this would just be V minus W. Okay, so let's try the next one. 2V plus 3W. Okay, so 2V means we're going to have two vectors of V. So right now, V is up to right 3. So instead I'm going to go up 4, right 6. So there's my 2V. Then I want 3W. So again, it's a 2, 2 here. So we're going to multiply that by 3, so it's going to be a 6, 6. There's 3W. So then we can go from the initial point of V to the terminal point of W. And that is our 2V plus 3W. Alright, and then we've got last one, 2V minus W plus U. Okay, so 2V. Horizontal's 3, the vertical's 2, so we're going to multiply those by 2. So our horizontal now is 6, the vertical is now 4. Just pick a point for your initial point. There's my 2B. Negative W, the opposite of W, so we're going to go in the opposite direction. So the horizontal and vertical, those are both 2s. We just want to go in the opposite direction. There's my negative W. And now I'm going to go to U. So my horizontal component for U is 1. The vertical component is 3. There's U. So now if I connect the initial point of V to the terminal point of U, there is our 2V minus W plus U. Talk about doing a position vector without drawing it. We are given vector, let's define the position vector of the vector V, which is equal to P1, P2. If P1 is equal to negative 1, 2, and P2 is equal to 4, 6. So if you recall, right here, a position vector, we're going to do x2 minus x1, y2 minus y1. So V is equal to x2 minus x1, 4 minus a negative 1, and then y2 minus y1, 6 minus 2. So our position vector then is 5, 4. If you want, you can put your i's and j's in there if you want. You can say that this is 5i plus 4j. Okay, so that's how many units are going from point P to point P2. You're going to be going 5 units horizontally, 4 units vertically to go from P1 to P2. Alright, let's finish up here with our adding and subtracting of vectors. So, let me start my page. Here we are given V is equal to 2i plus 3j, which is the same as 2, 3. W is equal to 3i minus 4j, and if you want you can just write that as 3, negative 4. So part A is supposed to find 3v. So v is 2i plus 3j. I'm just going to multiply each component by 3. So that becomes 6i. Whoa, that was not an I. 6i plus 9j, which is the same as 6, 9 in that algebraic form. Part B, 2v minus 3w. So let's just take a look at 2v first. I'm going to just do it in the algebraic form. 2v, that's going to become 4, 6. And from that, I want to subtract 3w. So 3w, that becomes 9, negative 12. And then we just want to make sure that we're keeping the horizontal components together and the vertical components together. So 4 minus 9, that's a negative 5. 6 minus a negative 12 is a positive 18. Oh, I'm sorry, I just realized I am starting with the wrong examples, aren't I? Whoa, this was C, and that was D. Let's go back up to A. Sorry about that. V plus W. So just taking the horizontal components, adding them together. So 2 plus 3 is a 5i. Vertical components, 3j and negative 4j is a minus 1j. So you can write that as 5, negative 1. Now let's do part B, V minus W. So again, we're subtracting the horizontal components, 2i and 3i, so that's a negative 1i, or a negative I. Then we're going to subtract the vertical components, 3j minus a negative 4j, that's a positive 7j. So negative 1, positive 7. So this should feel kind of like when you were doing matrices last year, where you just have to make sure that you're adding and subtracting those corresponding parts together. Alright, then let's jump back down to part E, where it's asking us to find the magnitude of V. So if you recall, magnitude is, there it is, the square root of a squared plus b squared. So we're only talking about the magnitude of V. So we're only using the 2i plus 3j or the 2, 3. So this is equal to the square root of 2 squared plus 3 squared.